Hello everyone, welcome back to our channel. So we are back with another video. So in the previous video we were discussing motion, and in today's video we will study force and laws of motion. So this is like the next chapter in class 9 CBSE physics, and we are going to learn about force and the different laws of motion. As we all know, we all might be familiar with the laws of motion, the very famous three laws of motion of Sir Isaac Newton. So in this chapter, we are going to study them. Okay. So what did we learn in the previous chapter? Let's just recall. We learned position, we learned origin, we learned the concept of motion, distance, displacement, isn't it? Then we learned velocity, acceleration. So all these things, that is, they are moving. But did we ever bother to think about why they are moving? What makes them move? What is the reason for their motion? So this cause behind a motion is what force is, isn't it? The cause of any motion. Why is something moving? Okay. If we throw a ball, or like if you roll down a ball or any object on the floor, on the ground, we can observe that after a certain amount of time it will come to rest. It will stop moving. So this is common for almost all the phenomena that happens in our world. So the people of older times, they thought that the natural state of any object is rest. Every object will prefer to stay in rest. But this concept got changed. This idea or understanding was changed after the intervention of Galileo as well as Newton. We will look into that a little bit later. Okay, so that means everybody not just always prefers to stay in the state of rest. There is something more to it. So what is your understanding of force? When we push something, it moves. When we pull something, it moves, isn't it? So these are all, if we hit something, it moves. So these are all the different ways in which we can apply force, and these are the ways in which some action happens, some motion happens in an object, isn't it? So if you apply a force on an object, there will be a change in its state of motion or state of rest. If an object is at rest, it will start moving. Similarly, you can apply force to stop a moving object. Similarly, for a moving object, by applying force, you can increase its speed. Similarly, you can decrease its speed. You can also change its direction. For some objects, you can compress it. That means you can change its shape as well as size. So these are the different ways in which force causes effect. Okay. Now let me discuss the concept of balanced and unbalanced force. So what is, the word itself is obvious. What is balanced and unbalanced force? Let's understand this by an example. So there is a table, and on the table we are keeping a block. Okay, so there is a block, that there is an object, that is, there is a box that I have kept on a table, and I am attaching two strings to it. This string is called X, this string is called as Y. Okay, so when you apply a force on X in this direction, what will happen? The object, the box, will move towards the right. Okay, now if you apply a force in this direction, what will happen? The object will move towards the left, isn't it? So in both these cases, the force is acting in one particular direction and the object is moving in that direction. Now assume that you apply equal amount of force in both these directions. Then there is no net motion, isn't it? It's obvious, right? If you pull with equal strength from here, as well as if you pull with equal strength from here, the object will stay at rest. That's for sure. So now you are pushing from both the sides, but from one side you are pushing more harder. That means assume that from here, through here you are pushing more harder. Here you are not pushing with the same amount of force. Okay, so then obviously the box will go in this direction, isn't it? So from this experiment, what did we understand? For an object to move, in this case, an unbalanced force is required. When the force was balanced, the object did not move. but when they were balanced, that is towards one direction, when the force was larger, the object moved. Similarly, assume that there is a large box. Okay, so there is a large box and I am trying to push it. What will happen? The box is very heavy. Okay, I tried, I didn't apply that much force. I tried to push it, but it did not move. Why is it not moving? Have you ever bothered? It is because, have you ever thought about it? It is because of the existence of another force called as the force of friction. So friction is a force that opposes motion. Whenever you apply a force on a body in one particular direction, friction acts in the opposite direction and it will resist motion. Okay, so you have to provide a force that can overcome this frictional force if you wish to move an object. Okay, so when I apply a force in this direction, and when applied force is in this direction, frictional force occurs in this direction. Okay, and this frictional force is most often it is provided by here, like that is the contact between the box and the ground. It's a rough place, right? The surfaces are rough and the frictional force arises. It's a contact force. You will learn more about frictional force later. But anyway, so when I apply say a particular amount of force, the object doesn't move because of the frictional force. It opposes. And what will be the value of frictional force? It will be equal to the amount of force that I applied. Why is that? Because we know that when the net force is not zero, that is, if there is an unbalanced force, an object will move. Here the object is not moving, then that implies the force on this object should be balanced. And when can the force on this object be balanced? When the applied force and the force of friction are equal. Okay, now I apply even more force, but still the object does not move because the object is very massive, it's very heavy. So then that means friction is also applying a larger force towards me, isn't it? So that the net force is equal, so that the forces on this object are balanced, so that the object does not move. Even harder I pushed, then the object might start to move, isn't it? So here the friction has a limit. I have applied force that is larger than the limit of frictional force. So then the body starts to move. So from this you have understood the concept of balanced force and unbalanced force. Okay. Similarly, if you're cycling, when you ride a bicycle, when you suddenly stop pedaling, what will happen? The cycle will come to rest after a while, isn't it? Why is the cycle coming to rest? It is because the ground, the earth exerts frictional force on the tires in the opposite direction of motion, and suddenly the object will come to rest. Earlier also there was this frictional force, but the force, we were also applying force, so the cycle was able to move forward. But now that is not there, so the cycle will eventually come to rest. So from these experiments we understood that an object will undergo motion or will remain in motion when a continuous unbalanced force is provided. What did we learn? That when a continuous unbalanced force is provided, only an object can move. But this is not entirely true. The actual way things happen is that an object will continue to move with a constant velocity or a uniform velocity in a same direction when the force acting on it is balanced, isn't it? And then there is no external force. So if already an object is moving, it will continue to move with the same velocity in the same direction if the forces acting on it is balanced. Okay, and no external force should act on it. So that is okay. So only when an unbalanced force occurs, an object will undergo motion. And now if this force is completely removed, if there is no force, then the object will continue to move with the same velocity. Okay, sorry, wait. So an object will move with a constant velocity in a particular direction when the net force acting on it is zero, that is when the forces are balanced. Now when you apply an unbalanced force, the motion will change. That means it can accelerate or it can decelerate. That means its speed can increase or decrease, or the direction can change. All these things happen when you apply an external force. Okay. So when the force gets unbalanced. But if this unbalanced force is removed completely, then because of that force that you applied, you apply an unbalanced force, right? So then the body will acquire a particular velocity. Suddenly you remove that force. Now your body will continue to move at that acquired velocity. Okay, it will continue to move in that velocity. But in real case scenarios, it will continue to move in that velocity, but slowly the velocity will come down because of the existence of friction. Because in our statement, I clearly mentioned that there are no external forces. Okay. Now let's discuss the first law of motion. First law of motion, it is put forward by Sir Isaac Newton, and he derived this law based on his understandings that he got from Mr. Galileo. Okay. So there is a very simple experiment that Mr. Galileo has conducted. I will explain that experiment. Okay, assume that the angle of elevation of both these are the same. You have a marble ball here. So these are like very soft surfaces. You drop a ball from here. Okay, it will go down along this path and it will go up in this path. As it goes down along this path, its speed starts to increase. And as it goes up along this path, its speed decreases. Isn't it? This is obvious. So Galileo said that if you drop the ball from this height, assume that from ground the height is h1. Here also the ball will reach the same height h1. Now if you drop the ball from this particular height, which corresponds to h2, okay, this height is h2. Correspondingly here, the ball will come down, it will reach here. That is at h2. Okay, so this is what Galileo said. Now let's do a different version of this experiment. That is, what did Galileo say? So we have two slanted surfaces. Two slanted surfaces and we have a ball. So if I drop this ball from a height say h1, the ball will reach here. Yeah. So this is at a height h2. Sorry, h1. Now if I drop from here, the ball should reach here, isn't it? But instead of that, I changed this surface, the elevation angle I changed. I made it steeper. Okay. So now the ball will, according to Galileo, if here the height was h2, what did he say? On the other surface also the ball will move until it reaches the same height. So that means it has to move until it reaches the height h2. So that means the ball will reach here. Now I decrease the angle of elevation. So that means here to here, if the distance is x, from here to here also the distance would be the same, x. But here to here, the distance is larger, isn't it? It would be something more than x, because now the angle of elevation is less. So the ball will have to move a farther distance to reach the same height. But Galileo said that the ball will reach the same height. Okay, now if I made it more elevated, then the ball will reach here, because it has to reach the same height. See, it is moving a larger distance, much larger distance, not equal distance. So what will happen if I continue to decrease the angle of elevation? I make the surface flat. What will happen? According to Galileo, the ball will continue to move as long, it will never stop. It will continue to move. The ball will move in a hope that at one time it will reach the same height. But the ball can actually never reach that height. Okay. But it will, so that it has no choice. It has to keep moving. But does this happen in actual cases? In actual cases, this does not happen, because the friction comes into play. And I have mentioned that these surfaces need to be smooth. By smooth, I mean these surfaces need to be frictionless. Okay, so that they will continue to move. But when there is friction, they will come to a rest after some time. Okay. So based on these understandings, Newton gathered the first law of motion. This first law of motion is also known as the law of inertia. It's very simple. Every body continues to be in the state of rest or in the state of motion with constant velocity unless an external force acts on it. Okay, which compels it to move, change the state, which is, okay, that is, an object remains in a state of rest or of uniform motion in a straight line unless compelled to change the state by an external applied force. Okay. So in other words, you can say that every object will resist a change in their state of motion. Nobody wants to change whatever their motion is. Okay. If it is at rest, it will prefer to stay at rest. If it is in moving at a particular velocity, an object will always want to stay at that particular velocity. Okay, now you assume that you are moving in a car. You are going in a car. So you will be at zero velocity with respect to the car. Okay, you won't feel like you are moving inside the car, isn't it? Now suddenly the car applies brake. The engine will make the car come to a stop. Okay, but what happens is that our body will continue to remain in that state of motion, isn't it? This concept is called as inertia. Okay, so our body will want to move at the same speed that the car was going, but the engine of the car has asked the car to stop. The brakes has asked the car to stop. But our body didn't get the information yet, so we will try to resist the change in our motion. Okay, because of which we will be what will happen when brakes is suddenly applied? We will move forward, isn't it? Because see, when you are moving in a car, if you are moving in a car, this is a car. Okay, what happens when you are moving in a car? The brake is applied, so brake will have to be applied in the opposite direction because car is moving in this direction. Okay, in order to stop the car, brake has to be applied in the opposite direction. So when brake happens in the opposite direction, our body will apply. Our body was in the moving in this direction, so a force will be provided in the forward direction. Okay, the inertia of our body will provide a force in the opposite direction, which will make us move forward. Okay, I hope you understood that. Similarly, so this is the reason why cars have safety belts. Okay, so if you are moving in a car at a very large speed, suddenly something came up, your driver will have to apply sudden brake. What happens when sudden brake happens? When there is a sudden decrease in the velocity of the car. But our body, which is in the state of inertia, it will prefer to move at that high velocity. But because of the brake applied, our body's inertia will apply a force in the forward direction and we will move forward. So there is a chance that we might hit the steering wheel or the front of the car and we might die. So in order to prevent this from happening, we wear safety belts, seat belts. Okay, this will provide a force in the opposite direction. When you move forward, the safety belts will push you backwards so that you will be protected from any sort of accidents. Okay, similarly when a car similarly when you are in a car and like it suddenly moves, it was at rest. Okay, you just boarded a bus or a car or any vehicle and it started to move suddenly. Okay, what will happen? You will move in the opposite direction. Why? You were at the state of rest. Now the car is moving in a forward direction. So your body was in this inertia state which was at rest. Suddenly there is a motion in the forward direction. Your inertia will resist that motion. So that's why you will be taken back. You will move backwards. Okay. This inertia you can also experience when your car or vehicle is taking a sharp turn at a very large speed. Okay, if it is moving towards the right, if it is moving towards the left, you will move towards the right. If your car is turning towards the right, you will move towards the left. Okay, so that is how inertia works. Okay. Now let me introduce the concept of inertia and mass. How is inertia related to mass? Okay. We know that, see there is an empty box. It is very easy to carry an empty box. Now you put lot of objects inside the box. Is it easy to carry that box? No. Now it is difficult to carry that box. You will have to apply more force. So what did you understand from this? Every object try to remain in its state of motion. So if the box is at rest, it will always want to stay at rest. So you will have to apply a force. Now if the box has lot of books in it, then its mass is higher, so it becomes more difficult to move it. That means you need to apply more force. That means now its resistance towards motion is higher. So that means the object will try to remain in its state of motion or rest even better when its mass is high. So that means mass is a measure of inertia. Okay. So that, for example, you have a cart. Okay, you apply a particular force and the cart will start moving with a very large acceleration, very high acceleration. If you apply the same amount of force to a train, almost nothing will happen, because the train is so massive that the amount of acceleration, the amount of force you provided is not enough to bring a significant acceleration. So from this you can understand that inertia, the tendency of an object to remain in its state of motion or that of rest is high when it is more massive. Okay, so we can quote this like this: inertia is the natural tendency of an object to resist a change in its state of motion or of rest. The mass of an object is a measure of inertia. Okay. Now we have a few questions. Which of the following has more inertia? A rubber ball or a stone of the same size? A bicycle and a train? A 5 rupee coin and a 1 rupee coin? So these answers are very obvious and simple. In rubber ball and stone of the same size, it would be stone, because stone is naturally more massive, more heavy. Okay. Similarly, between a bicycle and train, that's a stupid question. Train, obviously it has higher inertia. Okay. Now what about a 5 rupee coin and a 1 rupee coin? Here the difference in inertia won't be as large as like a train and bicycle, but still 5 rupee coin is much more bigger, like more heavier compared to 1 rupee coin. So 5 rupee coin will have a larger inertia. In the following example, try to identify the number of times the velocity of the ball changes. Okay, a football player kicks the football to another player of his team, who kicks the football towards the goal. Okay, the goalkeeper of the opposite team collects the ball and kicks it towards the player of his own team. Also identify the agents applying the force in each case. Question is very easy. Okay, so you have a football post, you have a goalkeeper or a goalie, so there is another, okay. So we have two players of team B and two players of team A. So our player from team B kicks the ball. Okay, it reaches player A, the another player of team B. Now from here he also kicks the ball. Okay, so the ball moves towards the hands of this guy. Okay, he holds it in his hand, and from here he kicks the ball to here. Okay, so in total, how many times has the velocity of the ball changed? Once the ball was moving with some particular velocity, so this footballer kicks the ball, so the velocity changed one time. Now it reaches another player of the same team. Okay, he also kicks the ball, so the velocity changed for the second time. Now this footballer kicks the ball towards the goal post, but the goalie catches the ball. So now the ball comes to rest. That means its velocity has came to 0, so the velocity changed for the third time. Now this goalkeeper kicks the ball to a player of his own team. Okay, so again from 0 velocity, the ball has acquired another velocity. So the velocity changed for 4 times in total. Another question is, identify the agent supplying the force in each case. In this case, the agent was B. Second case also it was B. Like the first player of this B team applied force in the first case. In the second case, the second player of the B team applied force. In the third case, it's the goalkeeper of A team that applied the force. In the fourth case, it's again the goalkeeper who is applying the force, because he's the guy who catches the ball when he applies the force. By applying force, he's the same guy who is kicking the ball to his player. So again, he is the guy who is applying or providing the force. Okay. Explains why some of the leaves may get detached from the tree if we vigorously shake its branch. Why only some leaves fall? Because all leaves are in the state of rest. They have that inertia which will always try to make sure that they stay at rest. But now you are applying a force because of which the tree is moving. So all the tree, the leaves, branches all undergo a to and from motion. Okay, so those leaves who has like lower inertia, okay, those leaves which are loosely attached to the tree, they will easily fall off because of their inertia. Okay, because they were trying to resist that motion and they are unable to, so they will just fall down. Okay. Now, why do you fall in forward direction when a moving bus breaks into a stop and fall backwards when it accelerates from rest? I already mentioned. Okay, when a bus is moving, okay, you are here in the bus. Suddenly the bus starts moving in this direction. You were at rest. Obviously, your inertia wants you to stay at rest. So inertia will resist the motion which is in this direction. So inertia will apply a force in opposite direction. Now you are here. Okay, bus is moving. Bus was moving in this direction. Suddenly the driver applies brake. So that means there is a force in this direction. Force due to brake will be in the opposite direction. So now your inertia was in here, the inertia was trying to make it stay at rest. Here the inertia is to keep your body moving in the forward direction. So now there is a force in the opposite direction. So our inertia will try to resist that force by moving in the forward direction. So the force due to inertia will be in this direction. That is why you fall towards the forward side when the bus applies a brake. Okay, and when the bus suddenly starts moving, you will go backside because of inertia. Okay. Now let's discuss the second law of motion. Okay. The first law of motion indicates that when an object first law of motion told us that the object will move only if there is an external unbalanced force. Okay. But we never quantified it. We never derived any mathematical equations to find its value. Okay. Now let's talk about how this mathematics of how, like, we know that when an object is moving, if you apply an unbalanced force, its velocity can increase or decrease, or the direction of the motion can change. So what does all this imply? What does it mean to have an increase in velocity or decrease in velocity or change in direction? All these three things means velocity is changing. If there is a changing velocity, if there is not a changing velocity, refers to a non-uniform velocity, isn't it? So what does a non-uniform velocity imply? It means there is an acceleration. So you can understand that a force causes an acceleration. Okay, so how is this force and acceleration related? The mathematical relation between these two is provided by Newton's second law of motion. Okay. Assume, consider a massive truck. Okay, it's very huge, but it is at rest. Will it cause any harm to anybody? No, it will cause no harm. Even if it is, now if it started moving, okay, it is moving at say 5 meters per second. So that's like 18 kilometers per hour, 20 kilometers per hour, very small speed only. 20 kilometers per hour isn't that large. But if it hits a person, there is a very high chance that that person might die, isn't it? Because the truck is so massive. Similarly, if you take the case of a bullet fired from a gun, it's a very small, tiny object. Its mass is much less, but still it can kill you. Here, the velocity of the bullet is very, very large, isn't it? So from this, you can understand that when there needs to be some physical quantity which combines this mass and velocity, because whatever force that you apply, it is acting, or it is connected with this mass and velocity together. Okay. In the truck case, even though the velocity was very small, mass was very high and it caused huge damage. In the case of the bullet, the mass is very small, but the velocity was very large, and hence there was a huge effect. Damage happened. So what is the quantity that connects these two? It is called as momentum. Momentum is again a vector quantity, and Sir Isaac Newton described this quantity for the first time. It's denoted by the letter P. Okay, P is equal to mass into velocity. It has the same direction as that of the velocity. Okay, so it's a product of mass and velocity. And what is the unit of momentum? Since the unit of mass is kilogram, and the unit of velocity is meter per second, the unit of momentum is kilogram meter per second. Okay. Now let us understand force. Okay, how is force and acceleration related? Consider a car whose battery is weak. So in such vehicles you might have observed in your house and all, when the battery is about to die, it's difficult to get the engine started. It will have some difficulty to get started. But once it started moving, it will move. So you must have seen, like, people will push the car. 2-3 people will push the car for a few distance and then the engine picks up. It will start and it will move. Okay. But see, if there is a car, there are like 5 people apply an immense force, but the car won't get started immediately. Simultaneously, it doesn't start. Only if you move and push the car for a particular distance, for a significant distance, the car will get started. So why is that? It's not just the change in momentum, isn't it? The car has a mass and the velocity is changing. So there is a change in momentum. It's not just the change in momentum, it is for the time through which this change in momentum was provided. That also is very important. So actually force, it is actually the time rate at which momentum is changed. So that is what the second law of motion states. Second law of motion states that the rate of change of momentum of an object is proportional to the unbalanced applied force in the direction of force. Okay. So the rate of change of momentum, the time rate of change of momentum, that is how much does the momentum change with respect to time, is what force is. And the momentum happens, the change happens in the direction of force. Okay. Now let's learn the mathematical formulation of second law. So let there be an object of mass m, of initial velocity u, of final velocity v. Okay, and it is moving for a time t. We need to find the relation between force F and acceleration a. So what all do we know? What is the initial momentum? Initial momentum P1, let it be, which will be equal to mu. Similarly, what will be the final momentum? Let that be P2. That will be equal to mv. So what will be the change in momentum? Change in momentum, which is equal to P2 minus P1. Final minus initial gives us the change in momentum. That will be m into v, mv minus mu. That's like m into v minus u. Okay, so that is the change in momentum. Now what is the rate of change of momentum? Okay, rate of change of momentum. Will be m into v minus u divided by t. When you say a rate of change of something, it is like you divide it by the rate of change. Okay, so like rate of change, mostly this is the time rate of change. Okay, so here this means that how much does the momentum change with respect to time. So for that you have to find the change in momentum and divide it with time to get the rate of change of momentum. And we have already learned that the rate of change of momentum is what force is, isn't it? So that means rate of change of momentum is equal to force. If I forgot to do something, change in momentum is P2 minus P1, and we know that force is proportional to rate of change of momentum. So m into v minus u by t, isn't it? And already we know that v minus u by t is what acceleration is. We know that v is equal to u plus at. From this, v minus u by t is equal to acceleration. So that means f is proportional to m into v minus u by t, implies f is proportional to mass into acceleration. Okay. So that when you convert this sign of proportionality to equal to, it becomes F is equal to K into M into A. This K is constant of proportionality. Whenever you convert a proportionality to equal sign, we have to add a constant of proportionality. But in SI units, the value of K is equal to 1 in 1 is equal to 1. In SI units, K is equal to 1. Since we will most often be using SI systems only, we can write force is equal to mass into acceleration directly. So what is the equation for force? M into A. So this is what the second law of motion states. F is equal to ma. Now what is the unit of force? What is the unit of mass? Unit is equal to kilogram meter per second square. So this is the unit of force, and this is called Newton. This unit is called as Newton, and it's represented by capital letter N. Okay, Newton. When you write a unit, and if the unit is named after a scientist, when you write it, the whole word, you have to make sure that the first letter is a small case, lower case, small letter. The symbol is capital letter N. So that is about force. So what is 1 Newton? It is the amount of force that a 1 kilogram object has when it is subjected to an acceleration of 1 meter per second square. Okay. So we can clearly measure force by, so there is a direct proportionality between force and acceleration. We were trying to derive the relation between force and acceleration. Now we know that force is proportional to acceleration. F is equal to ma. Okay. Now have you ever wondered why when a cricket game, when a batsman hits a ball and goes up and comes directly to the hands of a fielder, he catches the ball, right? And the batsman gets out. So during that time, generally when a bowler catches a ball, when a fielder catches a ball, he will often catch the ball like this, isn't it? He will gradually pull the catch the ball. It's not a direct catch. He's not enclosing the ball directly. Okay, why is that? Why is he catching the ball by taking some time? There is a reason for this. Okay, because see, when you catch a ball, the ball is coming at a very high velocity. When you stop it with your hand, the velocity changes to 0. So the change in velocity is very, very huge. Okay, so if you increase the time of this change in velocity, the force will decrease. Otherwise, because of the change in momentum being very high, okay, the force applied will be very large. So the fielder will feel hurt, will feel more pain. So in order to avoid that, he takes more time. Okay, so this is actually another physical quantity called as impulse, but we are not going to discuss it here. Okay, this is the same reason why when somebody does high jump and all, they will provide cushion beds. Okay, or they will provide sand. This is to soften the blow. What happens is that because of this, the time for the player to come to the athlete to come to rest is increased. He has now more time. So because of that, he feels less pain. Similarly, a karate player will be, you might have seen that they will be able to break large blocks of ice into 2 pieces. This is because they are applying force for a very small amount of time. So the change in momentum is very large, and it happens for a very small amount of time. The rate of change of momentum is very large, and hence the force applied in total is very large, and hence it will cause more damage. Okay, if you are slowly kicking it, like hitting it, it won't cause much damage. Okay, now the first law of motion can be derived from the second law of motion mathematically. Okay, and how is that? We will see that. We know the second law of motion, it states that F is equal to ma. F is equal to ma. Or in other words, we can write that F is equal to mass into velocity minus, which can be written as force into time equal to mass into minus u. Now what happens if F is equal to 0? If F is equal to 0, F is equal to 0, implies m into v minus u will be equal to 0. Doesn't matter whatever the time is. If f is equal to 0, ft will go to 0 and m into v minus u will be 0. That means mv minus mu is equal to 0 or v is equal to u or mv is equal to mu. So this is called, so we got v is equal to u. That means the body will continue to stay in the same, will continue to move with the same velocity. The initial velocity and final velocity became equal when the unbalanced net external force was 0. Okay, so when the external unbalanced force is 0, the body will continue to remain the same velocity. Okay, and if this u is equal to 0, then v will also be equal to 0 if u is equal to 0. That means if the body was in rest, it will try to remain in the state of rest. So when no force, when external force is equal to 0, the momentum of a body is conserved. You can see that u is the initial velocity, m is the mass of the object, v is the final velocity, m is the mass of the object. So this is the initial momentum and this is the final momentum. So initial momentum is equal to the final momentum. So that means when external force is 0, the momentum is conserved. Okay. Now we have a few examples. And then we will discuss the third law of motion. But I guess for today this is enough. We learned the first law of motion, we learned the second law of motion. Okay, so by this we will end today's video. Thank you. Let's meet in the next video.